Good morning, everybody, again. My name is Matteo del Corso, and in CAREL I am an application manager following all the applications, all the solutions that we make for condensing unit and compressor racks. So today we are going to see a presentation. We are going to have this overview of our solution portfolio for CO2 racks and condensing unit. Of course, because before starting to go in deep detail with our product, I would like to speak a little bit about the history of CAREL. So this company was born in 1973, and at that time we were supporting a little bit different market. So we were makers of electrical panels, of course, for HVAC and refrigeration application, but just the panels. Then in 1984, we started to make our first programmable controller, and then we start to develop other important products to support our partners on the production of units for air conditioning and refrigeration. So we made the electronic expansion valve, for example, and then around 10 years ago, we made our first controller for transcritical CO2 application, the pRack, that in the last years has a lot of different evolution, coming finally into the last two innovations that are the use of electronic modulating ejectors and DC inverter drivers for brushless compressors that are now used also on CO2 applications. Let's say that in CAREL we have one of the most complete offer for CO2. I mean, not just the components, because of course we have probes, drivers, electronic controllers, HMI, so a lot of different components that you can use in your unit. But another important feature of CAREL is that we are present in all the world, worldwide, with 25 local subsidiaries and 9 production facilities. So that means that if you need training, if you need support in your language, in your country, in your region, you can ask to the local subsidiary, and we can come and support you live in your country. To complete this offer is also the possibility to have some cutting-edge technologies like EMJ, so our electronic modulating ejectors, and of course the DC inverter for the brushless compressor that we now use also on CO2 application for refrigerating system. Just to have an idea of our controllers range for the different applications, we have controllers like Kiku, you can see on the bottom, on the left bottom of the slide, that is made for DC inverter condensing unit. And then we start with the pRack range that is supporting small condensing unit with a compact and small size, but also very small racks, for example. And by increasing the size of the pRack with the medium and the large board, we can support medium and big capacity range of units. These kind of products, I mean the medium and the large, can be combined even with a multi-DC controller that is used to manage multiple DC compressors in the same line, and can be combined also with ejector, with the management of ejector, and with the pRack network manager that is integrating the ejector also with the working condition of the cabinets. Just to start, I would like to give you an introduction of what are the standard CO2 solutions for CAREL. So the possible circuits, the possible configuration that we can support as standard products are the cascade systems, the pumped system that are similar each other because they are divided, the circuit, the design of the unit is divided in two circuits, a primary and a secondary. And of course, we can support transcritical booster racks that, in my opinion, they are very widespread in Europe, but also in all the world, and we can consider as a standard technology right now. Speaking about the cascade systems, what CAREL can provide is a one-stop shop solution, because we can provide not just the electronic controller, but also some different components that can be integrated into the units, like the valves, drivers, probes, but also in the rest of the system, like the MPX Pro to control the cabinets, or Ultracella to control the cold rooms, and of course, leakage detectors and supervisory system to manage and have an overview of all the system. From the pRack point of view, in subcritical CO2 racks like Cascade, we can manage, of course, the primary circuit with the compression lines and gas cooler, or condenser in this case, the secondary part of the circuit with the compression line, and of course the intermediate heat exchanger that we use to keep the CO2 in the secondary circuit always in subcritical conditions. Very similar to the cascade system are the pumped system. The main difference of this system is that usually the primary circuit is just used to condense the CO2 in the big receiver, in the big liquid receiver that is used to pump the refrigerant in liquid phase on the medium temperature cabinets, and with expansion in the low temperature cabinets or cold rooms. Of course, pRack is able to manage all the compressor lines, the condensing lines, but also the intermediate heat exchanger. So it is synchronizing all the needs of the pumped rack. An important feature that is valid, of course, for the pumped system, but also for the cascade and the transcritical booster system that we will see, is the DSS function that synchronizes the needs of the low temperature compression lines, for example, the one of the right of the secondary circuit, with the line 1 that we use in the primary circuit to condense, how can I say, to keep in liquid phase the CO2. So for example, if there is a request on the line 2 in the secondary circuit, we activate the line 1 in the primary in order to pre-cool the CO2 and be prepared for this request that is coming from the low temperature side. Then we are coming to the transcritical CO2 booster racks. Even here, the pRack controller can support all the needs of the rack. So, of course, the compressor lines, and in this case, even the parallel compressor lines. So the lines that we use in case of high temperature and high mass flow coming from the receiver, high mass flow of flash gas coming from the receiver in high temperature conditions. At the same time, this controller is able to manage the transcritical valves, high pressure and flash gas valve, some heat recovery system, 2 heat recovery system, and some more features that are, for example, I don't know, the water chiller function, or other special features that you would like to manage with this controller. These are our standard CO2 solution, let's say. What we would like to bring into the market very soon is the pRack HS. So what is pRack HS? From the software functions, from the software features point of view, it is completely the same of pRack 300 and pRack 300T, the transcritical version. But in this special release of the hardware, new release of the hardware that will come by the end of this year, we improved the speed of this controller. So HS means high speed, and it is 3 times faster than the previous one. So what does it mean? What are the benefits of higher speed for the controller? It's very simple. For example, you can save time on the field during the commissioning by making the configuration of the system, but you can save time also during the unit configuration on the factory, because upload, configuration, download, software modifications in terms of parameters is very, very fast compared to the previous one. Of course, another important benefit is connected to the reduced downtime of the unit in case of blackout, because the reboot of this controller is faster compared to the previous one, and we can avoid a lot of alarms that can come when the controller is offline in these special conditions. But let's say we cannot release a new hardware without new features. So this hardware in its transcritical CO2 version will come also with more features, like the possibility to manage 2 inverters in the medium and in the low temperature lines, and also the water chiller CO2 improved feature that actually is already present also in the standard pRack, but we improved a little bit even this feature to make it more user-friendly. Okay, so now is time to speak about our high efficiency solutions for CO2 condensing unit racks. In CAREL, when we speak about high efficiency, we speak about continuous modulation. So what does it mean, continuous modulation? It means that in your rack, there are some devices able to modulate with a wide range of modulation and match perfectly the load conditions required by the evaporators, by the cabinets, by the users of this cooling capacity. And these devices are, of course, DC inverter compressors, but also electronic expansion valve and electronic modulating ejectors for transcritical CO2 racks. These kind of special devices that improve the efficiency of your unit can be fitted in several applications in order to match the cooling capacity requirements of every supermarket size, from the convenience store, so very, very small stores, up to the big hypermarket sizes. So starting from the small sizes, we have HICU, we will see HICU, that is the solution for condensing unit. And by putting more BLDC compressors in parallel, we will see the pRack multi-DC option up to the pRack, how can I say, the pRack transcritical for booster system that can manage ejectors and can coordinate the use of an adiabatic cooler called Chill Booster. Let's start with a quick overview of our DC inverter technology. So with DC inverter technology, we speak about DC inverter drives that are designed by CAREL in order to manage permanent magnets, variable speed compressors. So this special compressor, the main feature of these compressors is the possibility to have a very wide range of modulation. And by the use of this DC inverter, we can increase and keep high the efficiency of the compressor, but also of the entire system at the end, even at partial load. So the COP of these compressors managed by DC inverter will be high at all the operating conditions of the unit. Another important feature is, of course, the wide range of modulation. And you can see on the right that the main difference between a DC inverter modulation technology and an AC inverter modulating technology is the range of modulation. So usually the AC inverters can modulate the compressor between 50% to 100% of the capacity, maybe 110. But the BLDC compressor with a DC inverter, with a DC driver, they can modulate between 20-25% up to 100%. And this brings us to consider the benefit that I already explained you before. Of course, our drivers have also other benefits, like the possibility to protect the compressor with the Class B software, and also the possibility to optimize, to have optimized parameters that are selected by CAREL in order to match the needs of every different model of compressor that we can support with this technology. So, the first application, the first solution that use DC inverter technology is ECU CO2 in this quick portfolio for racks and condensing unit. When we're speaking about ECU, we are speaking about a complete solution that includes electronic expansion valve that you can see on the bottom on the left of the slide. So electronic expansion valve for HPV, so high pressure valve and flash gas valve, electronic controller, of course, the driver for the Toshiba, in this case, rotary CO2 compressors. But also you can see a little bit more on the right, there are other two controllers that are Ultracella and MPX Pro. These controllers are used to manage the cabinets and the cold rooms, because ECU can communicate with the users, with cabinets and cold rooms, and has an additional, how can I say, fine-tune of the working conditions of the unit in accordance to what the cabinets, the users are requiring in real time. So in this way, we can improve the efficiency, the operating condition of the unit, but at the same time, we can keep the temperature inside the cabinets very, very stable. And that means that the food can last more in the cabinets, and the customers have more time to bring this food. And of course, the end users, the retailers in the supermarket, they have more time for selling the food. This solution is completed by some tools for an easy installation and configuring, and of course our remote supervisory and remote services for the total connectivity by remote of these units. But what happens if you put more than one compressor, rotary, Toshiba rotary CO2 compressors? Then you have a multi-DC booster solution. So you have more than one compressor in parallel that is increasing the capacity of these small, how can I say, condensing unit or small booster rack if we have, for example, two lines. So in this way, we can increase the capacity of the unit up to 30-35 kilowatt in medium temperature line, and up to 8-10 kilowatt in low temperature line. And the main point of this solution is the further increase of the modulation range, because you can imagine that if you have one compressor that can modulate between 20% to 100%, and then you put 4 in parallel, if one of them is active at the lower speed, it means that the modulation range is further extended from 5 to 100%. So an extremely wide modulation range that you cannot match with other units into the market. Of course, this solution is completed by an advanced oil management that we will see in the next slide. And it is really perfect for retrofits of old HFC units, especially in urban installation, because this solution has very low noise compared to the semi-hermetic reciprocating compressor solutions. And it is very, very compact. So you can put it inside the store with a remote gas cooler or outside the store according to the needs according to the space that you have available in the supermarket and around the supermarket. Again, just to give you an idea of the products that we can provide for this solution, there are electronic expansion valve for transcritical valves management, drivers, controllers, and the Toshiba CO2 compressor that are available, of course, for the multi-DC booster rack, but also for the EQ solution that I was speaking before. Let's have a very quick overview of the system that you can see on the right. So pRack, the transcritical version, is managing more or less all the needs of the unit except for the DC drivers and the electronic expansion valve that we use for the oil check, that is in charge of the PR multi-DC controller. If we speak about the oil check and pressure and oil level balancing valves, these devices are fitted on the side of the compressor with an inlet temperature probe and outlet temperature probe in order to check if there is oil inside the compressor, and if not, activate the oil refill from the oil reserve. At the same time, these valves can make the equalization of the pressures and of the oil level of all the line of compressors in parallel. Please consider that this solution is available, of course, for all our customers because it is a CAREL patent pending. Let's have an overview of other improvements that we can make for standard booster system with reciprocating technology. So how we can improve the efficiency of these systems. Of course, on the left, you can see that there is the heat reclaim possibility. So in order to recover some waste heat before the gas cooler for floor heating or domestic hot water. There is the eco compressors, I mean the parallel compression line that you can activate in case of high external temperature in order to manage the high mass flow of flash gas that is coming from the receiver. But then there are also other possibilities that are more recent, more innovative, let's say, that is the chill booster options, so an adiabatic cooler that you can fit on the gas cooler to manage the temperature peaks during summer, and the CAREL electronic modulating ejectors that we will see in the next slides. So speaking about the gas cooler, again, this is a spray pump, an adiabatic cooler that you can fit into the gas cooler. Oh, sorry, let me give you a couple of seconds to drink some water because I need a break. Sorry again. So I was saying this is an adiabatic cooler that can be fitted on the gas cooler, and by the adiabatic effect is able to reduce the inlet temperature of the air that is coming through the gas cooler of about 5 to 10 Kelvin degrees. And at the same time, it is able to increase the efficiency of all the unit of up to 8 to 12%. For example, by bringing back the operating condition of the unit into subcritical operating conditions. But there is another point that is, in my opinion, very important, and you need to consider for the application with adiabatic coolers. We cannot say that. How can I say? In the last 2-3 summers, we saw an average increase of temperature. So we are seeing a lot of high temperature peaks during summer. And in my opinion, this is of course my personal opinion, but this is due to the global warming, global temperature increasing. So this is something that we have to consider because this is real. What Chill Booster can do to, how can I say, to manage this special situation that will be more frequent in the future. If you install Chill Booster, this can shave the temperature peaks. So it is very good for retrofits. So where the gas cooler maybe was sized for the temperature of 2-3 years ago or 4-5 years ago that were lower. Now with Chill Booster, you don't need to change all the gas cooler. You just need to put the adiabatic system and be prepared for the temperature peaks that will come. At the same time, this device is also good for new installation because by adding the Chill Booster, you don't need to size the gas cooler for temperatures like, I don't know, 40 to 45 degrees that are maybe happening just 1, 2, 3 times per year. So with the Chill Booster, you are keeping in safety conditions your gas cooler, your rack from these high temperature conditions that are becoming more frequent in these years. Of course, if we would like to improve the efficiency of the unit in warm climates, but also in all the temperature profiles, we can fit our EMJ, our modulating ejectors. They are available in 6 sizes from 20 to 135 kilowatt. And you can put up to 3 ejectors in parallel in order to match the requirements in terms of capacity of your rack. The main feature of these ejectors compared to other solutions that are present into the market is the real continuum modulations. So this technology that is coming from our experience with electronic expansion valve is also present into the electronic modulating ejectors, and it is used to improve, to make very smooth the regulation and very stable the conditions and keep very stable all the condition, the working condition of the rack. At the same time, this is a vapor ejector, so it's very good for warm climates. And we have a special synergy with cabinets in order to match the operating condition of the racks with the conditions that are happening on the cabinets and cold rooms sides. Another important benefit is that by fitting ejectors in the rack, another thing that is coming is that with high temperature conditions, the cooling capacity of the rack can be boosted, can increase because of the use of the ejector. And in the next slide, I will explain why. And this thing brings us to think that with ejectors is possible or to increase the cooling capacity of the unit, or to remove, for example, one compressor in order to reduce the cost of the unit, because you have the ejector that is managing the special transcritical high pressure and high temperature conditions. So in this slide, it is explained very quickly the ejector concept that use the Venturi effect in order to bring a low pressure fluid that is coming from the medium temperature cabinets in this case, and it is pumped into the receiver by using a motive, high pressure, and even high temperature fluid that is coming from the gas cooler. So into the first section of the ejector, the two fluids are mixed, and they are reducing the pressure and increasing the speed in the convergent. And then in the divergent, they are reducing the speed and increasing again the pressure in order to be pumped into the receiver. So if we look to the EMJ mode on the right of the slide, you can see that all the fluid with the CAREL configuration, all the fluid that is coming from the medium temperature cabinet is managed by the ejector and pumped into the receiver. At the same time, by switching the three-way valve, the medium temperature line and the parallel compression line, parallel compression lines are working at the same level of pressure and are bringing the fluid from the receiver. So we have two main benefits. One is that most part of the mass flow is managed by the ejector, so all the medium temperature load is managed by the ejector and doesn't need to be managed by the compressors. And the other benefit is that all the lines are taking the gas from the receiver at a high level of pressure by reducing the delta P and the workload conditions for the compressors. This is an overview. As I told you before, the CAREL modulating ejector is a vapor ejector. So it means that the efficiency of this device will increase with the average temperature, with the climate profile and the average temperature that you will have in the country where you install the unit. So, for example, if we look to Miami or Rio de Janeiro, where the average temperature are more than 20 degrees, you can have a saving up to 20%. But if you look to Europe or South Africa or China, with a lower average temperature between 10 degrees C, you can still have a good benefit in terms of energy saving, that is from 7 to 10 to 12%. So this technology match, of course, better temperature profiles, high temperature profiles, but is also working on mild temperate climates. And it is available and you can use, of course, in all the countries you prefer. If we look, for example, to Australia, that has some summer peaks that are quite high, and but also some winter, how can I say, low peaks that are quite low. This technology could be interesting, especially in the location where the water for an adiabatic cooler is not so available, or the humidity close to the coast is too high for an adiabatic cooler. So you need to see the ejectors not just a device that is improving the efficiency of the system at high temperature, but also a device that can replace other technology that requires other things like water, for example, that are maybe not available in all the locations. And this is bringing us to speak about CAREL IoT services. Before to speak about the services, I would like to give you a quick overview of our supervisory system. So a supervisory system is a device that is collecting and showing and make you able to change check the units, the cabinets, and change parameter, optimize the working condition of these devices. So the supervisory collect all the variables from cabinets controllers, racks controllers, condensing unit controllers, and show you into a local device like a laptop via Wi-Fi or by remote if you have a remote connection. So you can log in and check how the system is working by looking to the different variables, by looking to the different condition of the different devices connected. But this supervisory system, as you can see from these slides, is necessary to collect, of course, as I already said, all the variables from racks, cabinets, condensing unit, and bring this information to our cloud platform that is called RED, our remote services platform. So with RED, you have the possibility to compare live if you have more than one supervisory system and of course more than one store to control. You have the possibility to compare the operating conditions of these stores and take also and undertake some actions. For example, you can check from the different stores if one store has more alarms than another one. So you can send the contractors, the installer, the maintenance people to check what is happening just on this site that is requiring assistance, instead of program a lot of visits in all the sites. At the same time, you can see the energy consumption profile of the different stores. So you can see if one store is consuming more energy comparing to the other stores with the same configuration. So you can go just there and check the configuration of the different devices in order to bring back to the best operating conditions. And what does it mean? It means that you can reduce operational costs and also energy, the energy, how can I say, power bill costs by improving the energy efficiency of these stores. At the same time, if the store is well tuned, you can have a very stable temperature. If all the stuff is working well, I mean, not just the compressor racks, but also the cabinets and the cold rooms, you can keep the temperature very stable without downtime, and stable temperature and stable humidity means also high food quality. So as I told you before, for ICU, the food in the cabinets, in the cold rooms can last more. You have more time to sell it, and the customer will appreciate the quality, the color of the food that is going to buy. This was my last slide about the CO2 portfolio. So I would like to thank you to attending this presentation, and I would recommend to visit our natref.carel.com website that is reporting not just the solutions with natural refrigerants for condensing unit and racks, but it also reporting some innovative solutions for the HVAC market, like chillers, like automotive applications, still with natural refrigerants. And now I would like to open the question and answer time. So if you have some questions, we will have, I think, around 10-15 minutes for this session. You can put your question on the Q&A button that is on the top of the Zoom bar, in the top of this of your screen. So I will wait for some questions from you. Seems that something is coming. So how is the receiver pressure controlled in ejector solution? The receiver pressure is floating. So we don't control the receiver pressure. This is just floating according to the lift that the ejector is able to provide in that specific working condition. So, for example, if the pressure, if the outlet temperature and of course the gas cooler pressure is high, we will have a higher lift. Let me make an example. Let's assume to have the set point for the evaporators like 29, 30 bar because we increase the suction pressure for the evaporators and we reduce the superheat set point. We will have a lift of about 6-7 bars. That means a receiver pressure of 36-37 bars. Okay, another question is coming. So, which is, in your opinion, the technology that will be more used in the future? This is, how can I say, this is a tricky question because, how can I say, I cannot tell you that there is one best technology for the future. For sure, I believe that CO2 technology, but even propane for other applications will be a good refrigerant from the future if you look to the regulations point of view. But regarding the applications, it depends on the market and it depends on the store size. So according to the size of the store, we can provide, the strategy of CAREL is to provide different solutions that use natural refrigerants in order to match your expectations in terms of cooling capacity for your store and also keep high the efficiency with natural refrigerants. Let's wait a little bit more if other questions are coming. Okay, since seems that another two are coming. You mentioned a decrease of superheat when using the ejector, but by how much do you decrease it? Okay, this is quite simple. So when we switch from the standard operating mode of the ejector system, from the standard operating mode of the unit from the ejector mode, we increase the pressure set point for the suction, not of the compressor, but I mean the suction of the ejector. So the probe is on the suction of the ejector, and this increase is from 26, 27 bar up to 29, 30 bar according to the operating condition of this rack. At the same time, we can decrease the superheat from 7 to 2K. So the delta is 5K more or less. And this is because our ejector is a vapor ejector, but is also able to manage a little bit of liquid in the suction. Not full liquid, I need to be very precise on that, but a little bit of liquid is possible to manage. And if all this fluid is going through the ejector, there are no issues for the compressors. This is another interesting question. Is CO2 refrigerant a solution for the industrial industry? For industrial applications, I think that in the past, ammonia and ammonia alone and ammonia plus CO2 were the most used technology, and of course even HFC refrigerants more in the past. But I believe that it is a trend that I'm seeing from our customer, from the market, that for new logistics centers, big warehouse, so big applications, there are increasing the request for big racks with a lot of compressors. So my answer is of course yes. I think that CO2 will be the best solution for the future, for sure in Europe, but also in the rest of the world for industrial application, because this is a trend. Year by year, we are seeing bigger compressors released by the compressor manufacturer, and more requests to have more compressors in the rack and special features for industrial applications. So yes, at the end, it is yes. What steps control is executed when heat recovery demand is increasing? Oh, this is another interesting question. When we have different possibility to manage an heat recovery, so it could be like on-off, but it could be also modulating. So let's refer to the modulating possibility. Your heating floor heating system, your domestic hot water system, whatever, is giving to pRack a 0 to 10 volt signal, and this signal is used from pRack to make different steps. So the first one is the opening of the three-way valve that is before the heat reclaim, and this three-way valve can be modulated. Then we will increase the HPV set point in order to increase the pressure into the gas cooler and the heat rejection from the compressors. Then we can increase the set point for the gas cooler in order to reduce the speed of the fans. Last but not least, there is the possibility to bypass the gas cooler with a three-way valve, and also to put a sort of false load close to the gas cooler or integrated to the gas cooler in order to increase, to have a further increase of the heat recovery capacity. Let me know if I answered to all your questions. If you have still some doubts, I have some minutes, so I can be available to answer to some more questions from all of you. Let's check if in the normal chat someone put some questions. Okay, seems okay here. Okay, seems that no other questions are coming. I would like to take, if you would like to answer, maybe I can make a question to you. So, which one of these technologies that I showed, I mean standard transcritical racks, DC inverter condensing unit, multi-DC compressor racks, which one, ejectors of course, which one of these technology looks from your point of view more promising for the future? So let's try to change, to give you the possibility to send me a feedback about that. Oh, in the meantime, that I'm waiting from your answer to my questions, I will answer to this question that is just arrived. So, what is ROI on the ejector system? Let me say, I don't have a real just one number for the return of the investment. But you can consider that the addition of the ejector system on the CAREL design is not impacting so much the unit design. So you just need, of course, to change the HPV valve with the ejectors, because our ejectors replace the HPV valve. You don't need an intermediate receiver, for example, and you need a three-way valve. So, in my opinion, these devices, additional devices, if you consider medium, big, medium, let's say 300 kilowatt compressor rack, it could be between 5 to 10% more on the total cost of the unit, on the total cost for the unit manufacturer. This cost, in my opinion, can be recovered between 2-3 years if you are in a, how can I say, let's say, mild temperature climate profile. If you are in a high temperature climate profile, probably you can return of your additional investment in 2 years. So this is more or less an idea of the return of the investment. Any answer to my question? So what is, in your opinion, the best technology for the future? I try to raise this point. So if you want, if you have the possibility to give your opinion, feel free. I think we will wait for another couple of minutes, and then we will close this session. Don't be shy. Answer this question. By the way, if they are not coming, I will give you my personal opinion on that. what I'm seeing, even close to where I live in Italy, in the northeast part of Italy, what I'm seeing in the last 2-3 years is the trend to make more proximity stores that are, of course, not big like a hypermarket or supermarket. They are smaller with less choice for the food, but they are more widespread. And how can I say this trend is also matching how the COVID situation changed our way, our life at the end, our habits. So if we look that more small formats, small stores are increasing, are opening in these years, it means that probably for the future we will see an increase of requests for applications connected to small units. So like EQ, condensing unit, where you can use one or more than one to fit the capacity required by the store, or you can use a multi-DC solution, so that is up to 30-35 kilowatt and 15-20 cabinets into the supermarket. So what I really believe is that in the future, small racks, small condensing unit application will rise a lot. And this is also due of the F-gas regulations that at the moment is impacting more the big units, but in the future will impact also the small units. So even the bakeries, even the butcheries, even these kind of small shops will probably need CO2 or propane solutions in the future. So I think that we can close this section. How can I say? I would thank you again for attending this live webinar, for making interesting questions, and I would say goodbye to the next one. Thank you very much.